So number 6 and 7 is just plug it in and you do the mod. If you have a question about mod or modulos, please email me and I'll be glad to go over the basic arithmetic for mod. Remember that our CPU and our ALU component of our CPU does not calculate remainders, so that's why you have to do the mod function with it as well. Look at number 8. Number 8 is part of your homework. Let me just get started with, just to start you out with this one on there. Number 8 is a very typical, it's a, if you think about it, it's not designed to make it difficult for you at all by no means with it. But let me see if I can place this in a place I can see both. So in here, like most anything, it wants you to declare. I always like to know what the data type of num1, num2, num3. I always like to know. In this case, it's new num. And there's a lot of concepts in there to reinforce in what you're looking at. Look at the way how this is declared. This is declared as data type, and the variables are separated by commas with it. This is the same thing as what you can do in here as doing int num1, semicolon, int num2, same thing, semicolon, int new num. This is all the same way. These 3 lines equal this line, okay, separated by commas. So what's the difference? Well, again, in your chapter 2 reading, you recall that the integer, this variable is 4 bytes. This is 4 bytes. This is 4 bytes. Doubles are 8 bytes, 8 bytes. So if I had a program that ran this, look at how much memory that I'm running right now. 4, 4, 4. That's 12. 12 plus 16 is what? 28 bytes I am taking up right now for these variables. Just give you perspective on how what it takes with it. Now, the question in this problem asked is, the key thing I want you to understand is the equal sign. So anytime when you have an equal sign, and when you think the right side equals the left side, you put in here, for example, A states num1 equals 35, okay, meaning you will put the right side, store that into the left side. This is a valid statement. What's not valid is this. I cannot do 35 equal num1, okay? Now, in algebra, this is okay, but in computer science, you're telling num1, store that into a number. That's not happening. It's going to have an error. So the concept I like for you to understand is in programming, whatever in time, when you come across with an equal sign, the right side equals the left side. The content of the right is put into the left. So in this expression, so A is valid. Look at B. Is B valid? Yeah, it's a valid, whatever number that is. Num1 minus num2, so store that into new num. That's valid. Look at this one. 5 is stored into num1. That's valid. Look at this expression. You put 5 in num1, so it's 2 plus 5 is what? 7. 7 is stored into num2. And then you come over here and you put, remember these are separated by semicolons, so they're new lines. So what do we say in num2 is? 7. 7 divided into 3 is what? Not 2 point something, I can tell you that. It's 2, right? Because these are integer. All these are integers. So it's only 2. 2 now replaces num1 is what? 5. So 2 is in the memory of 5. So let me just demonstrate with you what's going on here in this. All right. So you'll get a chance to do this in chapter what's called the hand trace table. I'll talk to you about that in a second with it. So let me tell you what's inside the memory. I'm just going to open up I'm using Excel partially because it's the grid, it's the rows and columns, so you see what's going on here with it. So let me come over here, place that over there. So based on what we just said, I'm just going to put this in a row for you to see what's going on here. So we said all the num1, I'm going to put this as a table header, num2, new num, right? This one is x, this is y. Remember, x and y are what? Are doubles, okay? So what do we start out with new num in part A? I'm going to put line A. Excuse me. In A, 35 is put in new num. In B, you went in, you took num1, subtract num2, which is a valid statement, by the way, right? They're just every one of these statements are independent. Now let's look at part C. In part C, you put num1 into new num. So this is 5. Technically, if I was writing this program, this would be strike through inside the memory with it, right? So that gets crossed through into new memory is 5. num2 says what? Take 2 plus num1 is what? 7. 2 plus 5 is now 7. Store that into num2. That's what this line says. Num2 divided into 3. Num2 is 5 divided into 7 divided into 5 equals what? I'm sorry, 7 divided to 3 equals num1, which is what? 2. Not 2 decimal something, no, because these are integers now, right? So this is why this is why I want to demonstrate to show you that 5 is being replaced by a 2. Okay, so I want you to go through this and finish out the rest of this. I started you on this, and if you want to do this as a hand trace table, I don't care, but it's just ask me if, tell me if this is valid or not valid. So I started you, A is valid, B is valid, C is valid. So look at this one, D. Think about this one. Num1 times num2 equal new num. Can I have new num assigned to this? Remember now I told you the right hand side has to equal the left hand side. Hint, invalid. That's wrong. Okay, so finish out number 8 for me. I'm done. I'm not finishing this out for you. Number 9, again, straightforward with it. Suppose that x, y, and z. You can do the same thing on here. Put x, y, z, and or w or int. What is stored in each one of the following? So if I had to put, like, this is number 9. So if I had to put x, y, z, and w here, right? W. So this is number 9 and number 9 here. So x is stored as what? In the memory of 9, and x minus 4 is what? 9 minus 4. Store that into y is what? 9 minus 4 is 5. So now this becomes 5. If you take y plus 7, do the parentheses first, was what? 5 plus 7 is 12, right? 12 mod 6 is what? Remember now, first number is larger than the second number, so 12 minus 6 equals z is 0, right? And then if you take what? This expression, you can finish out the whole thing, right? I'm not going to do the whole thing. X times z, x is 9 times z is 0, divided into y, 0 divided into 5 is 0, minus 3 is negative 3. So again, finish up the rest of this. Do the parentheses first and then the mod, so on. All right. So that gives you a flavor of where we're going with this thing. Look at number 10 for me, would you? Which one of the following variable declarations are correct? If a variable declaration is not correct, give me a reason that provides the correct variable declaration. So in here, I want to minimize this. In here, if you look at which one of the, so far, look at line 1, double conversion 2.5. You give them this some sort of constant. This is a good declaration. Line 1's good. Look at this one. Char, character is the data type, and grade. Remember now, char, you put this in a apostrophe, but look, you can't have a B plus. It has to be 1. Either B or a plus. You can't have both. Char is only 1 byte. So this line 2 is invalid. Look at this. What's wrong with this one? Double 28.5 equals num. The right-hand side is a variable. Store that into some constant. This needs to be flipped back and forth. So line 3 is invalid. String message with this. Okay, so look at this. What's wrong with this? Double quotes here, single quote here. That's what's messed up. Anytime you have a string data type, it has to be double quotes, okay, like a quotation mark. Look at line 5. What's wrong with line 5? You can't. Okay. What is this years here? It doesn't make sense, right? So that's invalid. Look at line 6. Int perfect square. That's a good declaration right there. That's good. Look at this one. 7. Is that good? Yes, that's valid. X, Y, and decimal float is another data type of 4 bytes with it. So you basically have line 1, 6, and 7 are correct. Everything else is incorrect. You see how I did that? All right. So let me check here.